So today we are adding tracing to a Deno HTTP server using the OpenTelemetry SDK and packages from NPM. They should just work with the latest versions of Deno. So I already have a very simple server being initialized here. It just calls an app controller, which returns hello world after sleeping for 30 milliseconds. So let's try it out. Let's do Deno run allow net index.ts, and let's do curl localhost 8080, and there it is, hello world. Now let's go ahead and get our tracer going. So I like to use the OTLP gRPC exporter. So let's just copy this guy, and I will wrap everything in a init tracing function. And instead of the basic tracer provider, we're going to use the node tracer provider. We'll talk about it later. I like using the batch span processor. So let's do this processor. It's this guy. And our provider, we have to register that, right? Yeah. And this, we should import this guy from npm OpenTelemetry. This is SDK trace node, okay, and then our OTLP trace exporter should come from here, and our batch span processor should come from SDK base. Okay, I do not want any options here. I will make this quicker by using only half a second to export, and this provider it has to be shut down later, so I'll just return it. And on index.ts, let's initialize our tracing. So we need tracing, it returns our provider, and let's wait for it to shut down on the graceful shutdown. Okay, let's see. So our OpenTelemetry dependencies wants to have access to our environment. So okay, hello world. So our server still works, but there's nothing being traced just yet. So I'll make a global tracer here. Should be tracer. This comes from API, and let's just do tracer. Let's provide the get tracer. Okay. And in here on our handler, let's do tracer and start a root span with our start active span method. So let's do HTTP handle, and then yeah, let's make this asynchronous and span, and after we run our controller. So let's just throw this error and do it finally, and let's return this. Okay, so yeah, I think this is fine. Let's actually give a name to our application. Let's do new resource. It should come from OpenTelemetry resources. Okay, and let's do service name. Let's do my app and service version. Okay. Now these keys should come from semantic conventions, right? So let's do a TTR service version and service name. There it is, service name and service version. Okay, so you come here, and this guy comes here. All right. Now, if we try and make a request, we should be tracing, but we are exporting nowhere because we do not have a collector running just yet. And I'm not really even sure where this is trying to export to. Let's make this more explicit by passing the URL here. It should come from a environment variable, but this is fine for now. And I'll just use Jaeger because this is a single command. So let's do our Docker run, and we are opening the 4317 port, which is the collector for gRPC. Now, if we open the UI in this port, so localhost 166.86, we have nothing just yet, so let's make a request. And there it is, my app. So it works. There's our HTTP handle span. Beautiful, and it takes more than 30 milliseconds because of our sleep in here. So yeah, so if we do not have Jaeger running, there is, as we saw, there is nothing being logged as an error because OpenTelemetry likes to fail silently. So from API, let's get diag, and diag log. No, it should be diag console logger, and our log level. Let's just do diag set logger with error level. Now, if we do the same request again, there it is. No connection established because there is nothing running on this port. Now, if we try again with Jaeger running, find traces. Come on, did you fail? Why are you not exporting, my friend? Oh, there it is, finally. Okay. Now, we also want to get an active span here. Not an active span, a new span here, right? So let's say that we have our tracer, start span, and let's call this app controller hello, and span, and let's make a try catch here. So on finally, we end our span, and there we go. Now, this span should be a child of HTTP.handle, and let's just hope that it works. And there it is, it's working. Now, the way that the library knows that this is in the same execution context and keeps track of the trace ID and so on to make this guy a child of this one is actually by using the node trace provider, which calls to the async local storage, right? So if we look at what this guy at context async hooks, so context async hooks, we have a async local storage context manager. So yeah, this is just using the async hooks node API, which takes care of the tracking the execution context. So this is very verbose. So we could do a decorator here for tracing, right? And it should be cleaner so that we get rid of all of these things. Let's go ahead and try to make it. So let's export function tracing, which receives a span name string, and it should return a decorator function. Now, so this is not good because this is starting a new root span. We do not want that. So let's just do span is tracer start span with the span name, and we just execute our original method, and there we go. There we go. This should just work, right? Except that this will not work because we need to use this guy's TypeScript decorators. So let's just use tsconfig JSON and do a compiler options with experimental decorators, and we have to say config is tsconfig JSON. Okay, so execute, and this should still work, right? Okay, and yeah, there we go. Now, we do not have access. This is complaining because I should just return reopen Vim, right? So let's add controller. Okay, so this is fine. We do not have access to the span here if we want to set attributes, right? But we could do it with, I don't know, get span, right? By making another decorator here. So this should be fine. Another way to get the current span is by using the async local storage. So I'll leave that as an exercise. Thank you very much.